Okay, well, good morning, TCA campers. This is Camp Director Bourgeois back at it again for day 3, remote live. I'm just thinking about, all being shut into a house and fighting people for meat and toilet paper in the grocery store. Today's movie recommendation, if your parents approve, is the Will Smith movie, I Am Legend. It's got that gritty, end of the world, apocalyptic feel to it, and you just kind of see a little bit of the crazy that comes out when you start to live in isolation from everybody else. I think it'll be an encouraging flick for most of you. I Am Legend, starring Will Smith. Beautiful. Or else you could read the book. I hear the book is very different than the movie. Like really, really different. Like the movie has like a disease that makes you a zombie, but the book had vampires in it. So I don't know. And also the book, I think, was a lot older, and so there wasn't modern day technology. Anyway, look at page 36 in your textbooks. Oh, also, before we get there, some people had said that it's a good idea to listen to me on increased speed, so you can listen to my voice at 1.5 times the speed or 1.5 times the speed to get through the video a little bit quicker. I think that's a good advice. If you can handle it, go for it. And then also you have the ability to pause and back up again if you missed something. So in case I increase the speed of my talking or decide to talk like a chipmunk, which I might just do because that sounds hilarious, then you could be like, wait, what just happened? And then back up and then play it at regular speed if y'all need to. But page 36 is a supremely important page for your studying. I would even maybe dog ear this page. That means fold the corner down, and so you're more easily able to come back to it because it's got all your vocab right there. It's got, complements and supplements and angles at a point. If you don't know what all of these mean, you should be, or know the properties of these, you should be able to look them up. So angles at a point are angles that all come together. They should all add up to 360 degrees, right? I still haven't figured out how to make the degree sign. I know there's a way. You just have to find the right combination of keystrokes. So vertical angles, alternate interior angles, alternate exterior angles, and corresponding angles. Make sure you know those very well. If you know the vocab, if you're good at vocab, this chapter can be very helpful to you. This chapter can be a boon and a feather in your cap. Just don't call it macaroni. I have no idea what that means. Actually, I do. I looked it up one time. I don't remember anymore, though. Stuck a feather in his cap and called it macaroni. Cool. Now, moving over. You saw the write and solve equations. Use the properties of all those different things that we know. We're looking at page 37. We're just going to wrap this chapter up. This kind of just brings together everything that we've learned so far. So we have all the properties of different kinds of angles that are universal properties. We're going to look at example 14. I'll do that. We're going to look at example 14, and it says in the diagram, line MN is parallel to line PQ. Find each of the following angle measures. Let's also assume, I think they want us to assume that ST is also a straight line. It's not parallel to anything, but it is a straight line. So let's make that assumption. So find each of the following angle measures. They're asking us to find the measure of angle 3. I'm going to go ahead and recreate this on the board as best I can. And it looks something like this. Why not? All right, and I'm going to ignore the little symbols on it and the points. We're just going to go with the angles. So they say the measure of angle 6 is given to us. This is 123 degrees. That's all they gave us. We're supposed to find the measure of angle 3, which is this one right here. So what do y'all think? Let's pause the video. Pause the video, figure it out, come back to it. Oh wait, this isn't guided practice. They give you the answer. Don't pause the video. What am I thinking? All right, so taking a look. We can see that these two angles correspond, n'est-ce pas? They correspond. They are corresponding angles. All right. So because this angle, this is a straight line right here, up and down, and these two are parallel to each other, that means they're going to be, these angles measures are all going to be the same. And if you think about it, that really makes sense. As I could draw any number of lines that are parallel, and they will all intersect at the same way. For those of you who are visual, or for those of you who maybe have some experience in, I don't know, carpentry or something, this should be pretty intuitive for you. And even those of you who can kind of eyeball it and say, yeah, those look like they're the same measure, it's because they are. They are corresponding angles. They are congruent. So the answer to the first part is the measure of angle 3 is 123, the same as the measure of angle 6 because they're corresponding angles. B, it asks for what's the measure of angle 1? Angle 1 is this one right here. Angle 1 should also be 123. Why is that? Well, you can say because it's all the answer they give you is, well, alternate interior angles, right? This is an interior angle, and this is also an interior angle. So this equals this. I would say, well, hang on, these are vertical angles, and since I already solved that one, I know that they're equal because it's vertical to this one. So 123 is the answer here too. And then C, it says, what's the measure of angle 2? Angle 2 is this little jobby right here. Ooh, that one's different, isn't it? There are a number of different ways that we can look at this. Since we know that this is a line, we know that these two angles must add up to 180. And so 180 minus 123 would give us 57 degrees over here. You see that? Do I need rainbow pen? Rainbow pen. Rainbow pen, there we go. I like it when it starts with a warm color. I just feel like it adds to the magic. So because that's going to add up to 180, also this is going to add up to 180, we know it's going to be 57 because they're supplemental angles. So you see how we've used all that knowledge that we've got so far to find the missing angle? Now let's pause. We're going to do guided practice number 4. Go. Okay, so hopefully you've paused the video, you've done guided practice number 4. Let's take a look at it together. Also, you're going to see, if you want to skip the solution and skip to the next part, I'm going to put a little red play symbol right there. It's like the play on your little player. That's going to say, hey, we're back at lecture, and I'm not explaining a problem that you already knew how to do. So for those of you that want to skip the demonstration, I'm going to do that. Look for that symbol. Fun times? Fun times. I might even color it in. Okay, so in the diagram, guided practice number 4, it says the line MN is parallel to line PQ. Line MN is parallel to line PQ. Find the measures of angle 1, 2, and 3. All right, whatever, 1 degree is fine. And we'll use black. Let's be consistent. They have it more upward slope, don't they? Man, I really hate it when they do that. It bugs me. Okay, 1, 2, and 3. We're looking for 1, 2, and 3. Looking at it right away, we should be able to tell that 1 and 2 are vertical angles, and that they will be the same. So the measure of angle 1 will equal the measure of angle 3, because they're vertical angles. And if you need to go back and watch previous videos or flip back in your page and kind of look at what's a vertical angle, go scan your book for that word vertical angle, and you'll see. But measure of angle 1 equals measure of angle 2, because they're vertical. Next, we see this angle, angle 3 over here, will be a supplement to angle 1. So we know that 180 degrees minus the measure of angle 1 equals the measure of angle 3. So I know that without even looking at the things, because these two are supplements to each other, these two are vertical. Now, at some point they have to give me some information so that I can finish solving this. The information they give me is that the measure of this angle up here is 81 degrees. Writing that small gets a little tricky with my fat sausage fingers, but 81 degrees. So, where can we start? Well, I can say that this angle and this angle are alternate interior angles, and I would be right. So that would be 81. Or I could say that this angle has a corresponding angle down here. Angle 2 is corresponding to the angle that was given. Since they correspond, they are also congruent. So they are 81. Also, these two are vertical, so whichever one I find first, I know that the other one's equal to it, because I already described that over here. That was a terrible circle. I feel like using my mouse is good for small drawing and writing, and using my finger is good for big writing. We'll stick to it. Then what did I say? Okay, so 81 is the measure of, so this is 81, and this is 81. Oops. 81. I don't know why I drew it with 0. So those two are both 81. Now, I have to use this second equation to find the measure of angle 3. What's 180? 180 minus the measure of angle 1. 180 minus 81 will be 99, right? Because 180 minus 80 would be 100. Subtract the extra 1 would be 99. Sorry, I just blanked for a second there. I briefly fell asleep, not to be alarmed. So yeah, so going back, 180 minus 81 equals 99, which is the measure of angle 3. All right, that wraps up lesson 6.3. So you should be able to finish all of those guided practice problems. Just glancing at it, it looks like there's a lot of really fun angles going on in there. All right, so now let's switch back it up. There we go. We are now on page, oops, yeah. We are now on page 43. As promised, for those of you who skipped the explanation of the guided practice problems, here is your big red triangle. Big red triangle. You may play the video now. All right, we're now on page 43. We're going to start with looking at interior and exterior angles. There is a hands-on activity, you guys. If y'all want to, you may do it. We're not going to do it here on this video because, I mean, I would definitely look at it. It's really fun. How they take the angles of a triangle, an equilateral triangle, or any triangle really, they cut the angles up and they can align the points into a straight line to show that a triangle angles always add up to 180 degrees. It is a property of it. That is the interior angles do. So I want to, there's a little bit of a warm-up exercise. Can you identify this triangle? What kind of a triangle is this? That's right, it's a right triangle. What kind of a triangle is this if I mark those sides as being equal to each other? It's an isosceles triangle. Who's that Pokemon? No, you guys never understand my references. Not even gonna try. Let's try this one. I'm gonna do my best. Oh man, this is gonna be tricky. All right, if all three of these sides are equal, what kind of a triangle is that? It's an equilateral triangle, because they are The sides are equal, the angles will all be 60 degrees, because I just told you that, and if you demonstrate with a hands-on activity by cutting a triangle into 3 pieces, you'll see that the angles, the interior angles that is, all add up to 180 degrees. They all make a straight line. Moving on, example 15. We're going to use the angle sum of a triangle to find an unknown angle measure. You should be on page 44. Math note in a blue box. The sum of the measures of the interior angles of a triangle is 180 degrees. This relationship is also called the angle sum of a triangle. It's very cool. So, looking at that, they have triangle PQR. The measure of angle QRP is 48. The measure of angle PQR is 31. Find the measure of angle RPQ, which is X. They take 180 degrees, subtract the known values, and that's the missing value, because we know in any triangle, so in a triangle with 1, 2, and 3, and too fat. Use skinny pen. 1, 2, 3. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Always the times. They will equal 180 degrees. So, example 15 says, hey, if they give you 2 values, you should be able to figure out the third value, because you just subtract them from 180 and there's your missing value. Let's do guided practice number 1. Pause the video, do it on your own. Cool, so you've paused the video as instructed, and now you've done the problem, and so now you can figure out the missing angle. So if we have 180, I'm just going to use this 180 that I already written down, 180 minus the known value of one angle, 35, minus the known value of the other angle, 57, equals 88, which is the value of our missing thingamajigger, our missing angle measure. Example 16 says, let's be specific to an isosceles triangle. Look at what the enthusiastic math student has to say. We are on page 45. Play the video. So on page 45, we're looking at enthusiastic math student says, in an isosceles triangle, the angles opposite of the congruent sides are also congruent. This should make sense. I mean, it makes sense to me. If it doesn't make sense to you, look at this triangle, meditate on it until it starts to make sense. We're on page 45. Enthusiastic math student. So not only are the sides congruent, but the angles that measure those sides are also congruent. Think about it like this. If these two sides are congruent, this angle right here grows out to this side, right? I could continue to extend this angle like this. I could continue to extend it, and if I do, and I also continue to extend this angle equally, they will both be equal, not only on the side, because if I extend them equally, the angle continues going. An angle is a degree of measure of, how do I explain an angle? I've been trying to meditate on what an angle is exactly. It's not distance, but it's rotation. It's a degree of, it's a measure of slant, I guess. It's a measure of how slanty something can be, or yeah. So basically, these two angles are going to be congruent. They are equivalent, congruent angles. So if this one is x, then this one will always also be x in an isosceles triangle. This one can be whatever. This one can be a curveball. So look at example 16. They say, hey, they gave it to us. This one is 40. What is the measure of the other ones? Well, I know that they add up to 180. That's true of all triangles. 180 minus 40 will equal 2x, because I have two of them. So I have three angles. I have 40, I have x, and I have x. They must all add up to 180 degrees. So if I subtract the 40, I have 140 left. So that 140 degrees needs to be divided between two angles evenly, which means 70 must be x. You can use algebra if you don't believe me. But you should always trust content from Magister Bourgeois. Pause. Try guided practice number 2. We are on page 46. Please try guided practice number 2. Ready, set, go. All right. Thank you for trying guided practice number 2, everybody. I hope that did not take you too long. It took me only a second to turn the page and look at page 46. We're going to do it right here. Guided practice 2. Wait, where are you? Where are you? The cursor blinks at me. It means I think you should be typing. All right, are you having fun? I'm having a lot of fun. More fun than a math teacher ought to be allowed to have. It's an isosceles triangle. Triangle XYZ is isosceles, and the measure of angle XYZ is 55. Oh, they reversed it. Those tricksters. Zip, zip, zip. So they say, hey, yo, everybody, this is 55 degrees. We're at both of these, 55 and 55. So what's 2 times 55 would be like 110 or something, right? So then what's x? I need to get all three of these angles up to 180. I've already got 110, which means I need 70 more. The answer is 70. That was a free one, you guys. No extra charge. Now, haha, page 46. Zip, 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 zip. Play. I'm gonna use the eraser machine. Woo-hoo-hoo. We're not on guided practice number 2 anymore. We are now looking at the new blue section. Explore and apply the properties of exterior angles of a triangle. Ha 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 ha. Oh, this gets a little bit crazy. But as in the diagram below, the sides of triangle ABC have been extended to form angles 4, 5, and 6. Because these angles lie outside the triangle, they're called exterior angles of triangle ABC. Angles 7, 8, and 9 are also exterior angles of the triangle. So the interior angle 3 and the exterior angle 4 are adjacent on a straight line. I'm going to draw this so we can look at this. So you extend out these lines like this. And they labeled these lines. So this is angle 1, angle 2, angle 3. What's 4? 1, 2, 3, 4. 4. 5. 6. Pretty crazy angles, you guys. But notice what... I already told you the interior angles will add up to 180. We already know that. Looking at this, I feel like some of you sleuths ought to be able to figure out what the exterior angles add up to? Hmm? Hmm? At least these three. If this extended line that I've made is a straight line, and this is, let's just say it's an equilateral triangle and angle 3 is 60. What must angle 4 be? 120, which is twice its interior angle. Now they're not always going to be twice, but we know that the average of the three angles that are interior, the average will be 60, which means the average of the exterior angles ought to be 120. So I believe that the exterior angles are going to add up to 360. Now, if I'm epically wrong, I'll probably just go ahead and edit it out, and you'll never know. Let's find out. Okie dokie. So, when we talk about, first of all, a little point of order here. When we talk about the exterior angles, we're talking about forming them exactly like this, because there is another picture where they extend these lines out like this. Woo, woo, and woo. We're only doing one set of the exterior angles, so you only take at each vertex, you're only going to have one extension coming off of it, and as a continuation of a side. You're not going to extend this one and then also extend that one out of the vertex. I mean, not for the sake of exterior angles of a triangle like we're doing. Okay, we're not doing that. Not for this exercise. But moving on. And then use the math note that each triangle has 6 exterior angles, 2 at each vertex. Yep, just like I showed. But when we're talking about they add up to 360. It's only this one plus this one plus this one. 4, 5, and 6. Extend a line out like that. So I feel like I've lost my place here. Let's see. So you can use these two equations. Let's see. I'm just going to read along. The interior angle 3 and the exterior angle 4 are adjacent angles on a straight line, so their sum must equal 180. You also know that the sum of the measures of the interior angles is 180. Next page, page 47. Top of page 47. You can use those two equations to demonstrate a property about the exterior angles of a triangle. That, since the measure of angle 3 plus the measure of angle 4 is 180, rainbow pen, and the measure of angle 3 and the measure of angle 7 is 180. Oh, they went and did it, didn't they? I have a galaxy pen too? Weird. So this is also 180. Therefore, angle 4 and angle 7 are going to be equivalent. As you can see, they would be vertical angles. Therefore, the measure of angles 3, 2, and 1 is also 180. You see that? So angle 1, angle 2, and angle 3 add up to 180. Angle 3 and angle 4 add up to 180. Angle 3 and angle 7 add up to 180. Therefore, angle 1 and angle 2 must equal angle 4. And angle 1 and angle 2 also must equal angle 7 because angle 7 and angle 4 are at vertical angles, so it makes sense that they would be equal to each other and also equal to 1 and 2. I feel like I went fast. If that felt like it breezed past you, you have the ability to hit rewind. But we know that all three of these angles add up to 180 degrees. Boom, boom, boom. You add up 1, 2, and 3, you'll get a straight line. If you add 3 and 4, you have a straight line. If you add 3 and 7, you have a straight line. So no matter how you'd make an exterior angle off of this vertex, it's going to be a supplement to angle 3. And any supplement to angle 3 is going to equal the sum of the other two angles. Always. This is true for angle 1 as well. Angle 1 and angle 6 equal 180. Therefore, angle 6 must be the same as 2 plus 3. Angle 5 is the same as 1 plus 3. So the exterior angle is always going to equal the other two interior angles. They're always going to equal. Number bond. Singapore math. Add any two interior angles together, you'll get the opposing exterior angle, or the measure of the opposing exterior angle. I feel like of all the things that we've done, this is probably the most confusing part, because it kind of brings together a lot of ideas that we've done so far. So if you need to camp on page 47 extra long, please feel free to. But we're going to look at example 17. I'm going to leave this right here so I can come back to it later. We're still on page 47. Example 17. We're going to find the value of the variable. Here we go, kids. We got a triangle. We got this exterior angle right here. There are a couple of ways that we can solve this. Nope, that's not what I wanted. I wanted this one. A couple of ways that we can solve this. This is 50. This is 60. And this is the one we're trying to find. X degrees. So, two different ways we can find this. First of all, we demonstrated up above. Zoops. Zootalor. We demonstrated up above that an exterior angle equals the opposite interior angles, right? So angle 4 equals the sum of the measure of angles 1 and 2. So we can just take 50 plus 60, and we know, that looks like a weird, I don't know. We can take 50 plus 60, and we know that it will equal this exterior angle because of that property that we've already just established. Let's suppose, guys, let's suppose that you forgot that rule. Let's suppose you forgot that rule. Oh my gosh, I remember Mr. Bourgeois did that video. He showed this to me, and I just forgot it. Oh dear. Don't freak out, because there's another way that you can solve this. If you remember that all of the interior angles of a triangle add up to 180, you should know that this one, that this angle equals 70, so that all three of these angles will add up to 180. Now that I know that this angle is 70, I can look at this and say, well, here's its supplement. The supplement means that they add up to a straight line. So now I have 180 degrees minus 70 to make the straight line. I know that x must equal 110. So there are two ways that you can arrive at the measure of the exterior angle of this triangle. Let's apply that to B. So this was A. Actually, they use a parenthesis. I prefer the parenthesis anyway. Let's do B. B. Holy simoles, look at all those lines. So many angles. All right, here we go. Zip, zip, zip. I don't know why it keeps losing contact with my finger. It looks like they extend this out to make an exterior angle, and then they go zip. They do a little thing right there. Switching to skinny pen. This is 55. I don't know, you guys, I'm freaking out. I'm freaking out. 45 and 30. Whoa, you guys. What do we know? Well, this gets a little more complicated, but we know that we should not freak out because Mr. Bourgeois said that he equipped us with everything we need to solve this problem. So we're going to trust in his words. He's only seldom let us down sometimes, but almost never. So we're going to trust that he knows what he's doing right now. So take a look. It's in a book. Rainbow pen. Oh, rainbow pen. It's 180 degrees. So we can solve it either of the same two ways that we did in number A, where we know that the measure of the measure of this angle is going to equal the other two interior angles that we know. So the measure of this angle is 75, right? So then we got 75, and then I know 75 is going to equal the sum of 55 plus y. Oops. Plus y. So I subtract 55 from both sides. I know y equals 25. Or excuse me, 20. I misspoke. Y equals 20. The other thing that we know is we know that we can find the other interior angle. We can find the measure of this angle. So if I know it has to equal, the sum of all the interior angles has to equal 180. I see 75 is already accounted for, so I'm missing 105. I also know that this is going to be rainbow penned, right? It's rainbow pen. And so I know that rainbow pen, I know 180 minus 105. Actually, let me rephrase this. 180 is going to be the sum of all three of these angles, right? This angle, and then this mystery angle y. So 180 is going to be the sum of 55 plus 105 plus y. I use my algebraic powers combined, and I know that y must equal 20. Skinny pen, you've let me down. This is some ugly, ugly writing. I wish a stylus worked on my screen, so I have to use my fat finger instead of using a nice, neat tablet-y pen. It's okay. So there's two ways to solve that. There's guided practice. We should do it. I have reached the bottom of the whiteboard. It won't let me go down anymore. I didn't realize I had a limit. I thought it went on forever. Awesome. Okay. Page 48. Guided practice. Do both of these problems. I will be fast about the solutions. Ready, set, pause the video. All right, you have unpaused the video, which means you are done with the guided practice. Just kidding. I was just playing with it a little bit. So let's take a look. The answer to number 3, x equals 70. Did you get x equals 70? The answer to number 4 is x equals 76. Now, if you did not get those, then please watch the demonstration. Let's see what we did wrong. If you did get them, you may skip ahead to the triangle part, the red triangle. Here we go, here we go, here we go, yeah!
Yep.
Come on, finger. Let's try that again.
Yep. Yep.
Pretty reasonable triangle, if you ask me. So, sacre bleu, zutalor. This is a missing value. This is 62. They don't give us the other interior angle, but they give us this exterior angle, which is 132. Now, if I gave you control of the rainbow pen, and we're going to switch to galaxy pen. No, rainbow pen. Let's be consistent. Rainbow pen, you should be able to see that that is a rainbow pen moment where it forms a 180-degree angle, which is a thing of beauty, which means that this little interior angle that's bugging us is a supplement. So we take 180 minus 132 to find this angle, which is, let's see, 180 minus, sorry, that'd be 48, right? I believe it's 48. They just give me the final answer. They don't give me the interim work. They don't show me the work in the book. So now that we know that that's 48, we can solve and find the missing angle by taking 180, subtracting 48 and 62. I can do this part in my head. That would be 110. And so that would make x equal 70. There is another way to solve it. You can, without finding this interior angle, you know that 132, I'm going to use, what is that, green? Green pen. We already know that the exterior angle equals the sum of the opposing interior angles. I make a Singapore number bond right there, so you know that 132 equals 62 plus x. So that would make x equal 70. I shouldn't have had to think so hard about that, but I wanted to make sure it was correct and do that math in my head. So two different ways that x can equal 70. Now, if you were waiting to see, so pause, I'm about to erase it, if you need to see this and copy it down. Woo! So now if you're waiting for the second problem, then hit stop your fast forwardizing. Here's the solution to number 4. Let me draw the triangles. Close enough. All right. Then we got x up here. We got 35 right there. We got 70 right there. Right there. We got 41 right there. Nope, that's not how you draw a 4. All right. Similarly, I'm going to do green solution, where we say that this big angle right here is going to equal, so this big angle is 35 plus x. I'm running out of space. 35 plus x will equal these Singapore number bonds right here. So I'm just going to rewrite that as algebra over there. 35, part of the problem is my screen keeps wiggling, plus x equals, can I just add 71? I'll just add it. 70 plus 41. I'm always trying to take shortcuts. I'm gonna combine these like terms. So that would be 111. And then I'm going to subtract 35 from both sides, and I'll get x equals, what's 111 minus 35? Ought to be 76, yes? X equals 76 is my answer. Fun times? I thought so too. All right. Use the property of interior and exterior angles of a triangle to find unknown angle measures. I thought we were just doing that, example 18. Don't tell us to do it again. We were just doing that. Fine. All right, triangle PQR is an isosceles triangle. Find the measures of angles 1 and 2. Notice, okay, so notice angle Q in that picture. Oh, sorry, here we go. We'll do this. Resume paying attention. All right. Maybe I should leave that up longer in case you're like really fast forwarding, booking it. Resume paying attention. Let's see. We are still on page 48. Drag it up here. All right. Now that you've seen that it's time to resume long enough, here we go. Woohoo! So, triangle PQR is an isosceles triangle. Find the measures of angle 1 and angle 2. What is angle 1 and angle 2? They are, yoo-hoo! Oh, that was terrible. Trying again. All right, why is this so hard? I think the problem is that if I need to isosceles this, I should make the extension be last. That looks better. Okay. So angle 2 that they want this one. And they want angle 1. Gotcha. And they give us this measure right here. It's 120. So they have two methods. I've always shown you two methods. Magister Bourgeois never steers you wrong. Almost never. Method 1, it says use the isosceles triangle to express the measure of PRQ. Oh, now you're giving us angle PRQ in terms of measure of angle 2. We already know that. These two angles are going to be equal, right? Let's use Galaxy. We'll use the highlighter. Use skinny highlighter. How skinny are you? That's the skinniest you can do? Okay. So we already know that these two angles are going to be congruent because it's isosceles. That was given. That these two sides are equal to each other. So the sides are congruent, which means the angle opposite that side is congruent, and the angle opposite that side, well, the angle opposite that side is congruent to the angle opposite that side. And when I say opposite, we have an angle that's formed by this side and this side. So those are like the legs of the angle. The opposite side is the side that does not touch the angle, right? It's kind of the side that's formed by the extension of that angle. I don't know. There's a lot of different ways to think about angles and sides in a triangle. Excuse me. I needed a sip of my coffee. Need it. Gotta have it. Okay. So, taking a look. Method 1. We know that these interior angles are going to add up to 180. Yes? We also know that they're equal, that these two sides are equal. So let's just call this one oops. Let's not call it oops. Let's call it X. And we'll call this one Y. Why not? We know that 120 we know that 180 rather will equal the sum of all three of these angles. This one and this one and this one, which is also X. So 120 plus 2X. You following? We can subtract 120 from both sides with algebra, and we'll get 60 equals 2X. Then we divide both sides by 2 and we get X equals 30. I feel like it's easier to put X instead of, what they do in your book is they say measure of angle 2. They do it like that. That's fine if you want to do that. I find that needlessly tedious. As long as we know what we are identifying, you can just go ahead and say X or B or whatever. So method 2. Oh, and given that, now that we know that, how do we find the measure of angle 1? We know that the measure of angle 1 is going to be number bonded to these two. So we know that 1 is going to be equal to its opposing two interior angles, which we've already established is 30. So the measure of angle 1 is going to be 30 plus 30, which is 60. Also, we can know the measure of angle 1, so we can work backwards from that rule. I'm about to hit the undo button a bajillion times, so pause it if you want to look at this some more, otherwise, woohoo! The other way we can approach this is by looking at the angles on a straight line. Actually, let's redo those. So if we look at the angles on a straight line, we know that, oops, we know that this is going to be rainbow pen right here, right? And it's going to be 180. So that means if these two angles are adding up to 180 and one of them is already 120, that means angle 1 has to be 60. Rainbowified. And then we can apply this and say, wait a second, I remember what Mr. Bourgeois said. He said number bond with green pen. He always did this number bond with this green pen thing. So we know that these two angles are equal. That's kind of important. If you don't already know that about the isosceles triangle, I don't know that either method is going to help you. If you don't know that those two angles have to be equal because it's isosceles. So, just saying. So they are going to be equal. They are equal. It's isosceles. And we know that the sum of those equals that. And so we've got 60 equals, we're just going to call it 2, we could call it 2 times the measure of angle 2. Or 2x if you want, if you rather. We divide both sides by 2 and we get 30 equals the measure of angle 2. This thing. Right there, 30. Capiche? Guys, we're almost done. Guided practice. Hit it. Page 50. I think I'm going to slide my whiteboard all the way over to the upper left corner for the next lesson. Page 50. Guided practice 5 and 6. Ready, set, go. Pause the video. Unpause the video. All right. Now then, triangle ABC is an isosceles triangle. Find the measure. Oh, first, here are the answers. If you did guided practice numbers 5 and 6, the answer to number 5 is 105 degrees. If you got that, pat yourself on the back and you can ignore my explanation, or you can watch it because maybe you'll find a new way of looking at the problem. The answer to number 6 is x equals 120. 120 degrees. Here is the explanation, and if you don't need the explanation, you are done. You can just completely stop watching this video, but you're going to miss the jokes if there are any. I don't know. I usually don't think of them beforehand. All right. I'm going to draw this triangle. That's how they say it in New England.
Zip. Zip. Zip.
All right. What does this mean? It means it's an isosceles triangle. And they say AB equals AC. Ha! That tells us it's isosceles. That line segment AB is equal to line segment AC. They also give us that this is 75. And they want us to find the measures of angle 1 we'll do angle 1 and the measure of angle 2. Sacre bleu and zoutelor. This is crazy. How can we find, oh, sorry, I gave you just the bottom answer. So angle 1 is 150, angle 2 is 105. I just gave you the number at the bottom. There are a couple of different ways of going about this. I personally, the first thing that I see when I'm looking at this is that I know that this angle must also be 75. Now that I know that, I know the measure of angle 2 has to be 105. Because I know that rainbow pen, right? This is a straight line right here. You guys are gonna like dream about rainbow pen. You guys are gonna come across the checkpoint, you're gonna see a straight line and be like, rainbow pen! It's gonna be great. Glorious. All right, so it's 105, right? Angle 2 is 105 because I need 105 plus 10 plus I need those two angles to add up to 180 because rainbow pen, because it's a straight line. Two angles that form together a straight line. They are supplements. Now that I know that that's 105, I also should be able to find the measure of this angle over here. So 75 plus 75 would equal 150, which means that this has to be 30 in order for all three of these angles to add up to 180. 180, right? I know that that has to be 30, and if that's 30, then that means this one is 150. Because, you guessed it, because rainbow pen. Because rainbow pen, that's a straight line right there. Cool. I'm not going to show you the other method because we've already seen that other method a couple of times. So if you want to see the other method, if you're desperate to see it, phone a friend because I am out of time. Next, Nummer D. Nummer 2 in seinem Buch. Triangle EFG is an isosceles triangle, and line EF is parallel to line HI. Oh, so many things we could do with that information. Find the value of x. Here we go, y'all. Zip. Parallel lines. Zip. Ooh, let's try that again. Zip. So these lines are parallel. They will go on forever and ever without stopping. E, F. That didn't really work out very well, did it? There we go. Beautiful. A little bit more of a facsimile of what you see in your book. So triangle EFG, two lines are parallel. They want us to find the value of x, which is right here. X degrees. Oof. All right. They also show us that this is isosceles with this little hash right here and there. So an isosceles triangle, I know I did not draw that to scale. You just have to trust me. They also give us one more piece of information that the measure of this angle that's formed is 30. So how do we find x? Well, looking at this, honestly, I'm not sure. It's not obvious immediately to me. Except, I'm looking at this, and I see two parallel lines that are intersected by a transversal. This is a transversal. So now we're pulling together stuff that we've already learned. So, in case you skipped ahead, go ahead and play. Woo! For those of you who fast forward it. So we have parallel lines intersected by a transversal right here. We also know that the measure of this angle is 30. So where's the alternate? So we have vertical angles. These two angles are vertical. If I completely muff this, I'm going to edit it because right now I'm not super duper confident. Also, let's just go ahead and, if I extend this, parallel line, transversal. We've got corresponding angles right here, yes? I believe this is a corresponding angle to that one. Not corresponding. Yeah, corresponding. It's a corresponding angle because it's on the same side as the transversal. One of them is interior, one of them is exterior. Those are corresponding angles. If ever I make a mistake, I'm vulnerable now to making mistakes, but I'm confident now that those are corresponding angles. If you make a correction, go ahead and make a correction after you watch this video. We will all have a good laugh over our bottles of survival water that we distilled in our water distilling kit for a zombie apocalypse situation such as we find ourselves in. So that angle is 30. That means this angle must also be 30 because we've already established that this is an isosceles triangle. Now then, if I have 30 plus 30, I know that all three of these angles have to add up to 180. So I know I have 30 plus 30 is 60. I need another 120 degrees. X must be 120. That's my story and I'm sticking to it. Look at that. Ha 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 ha. Yes, indeed. Oh, you know what? I didn't have to lack confidence because it says right there in the book, corresponding angles. So the measure of FEG must be 30 because it corresponds to this angle right there. Ugh. Nailed it. Okay, so X does equal 120. I didn't realize I gave you those little blanks. Measure of FGE equals the measure of FEG. There you go. There's your answer, kids. Have fun with the homework. I'll see you next time. Bye-bye.